Hello and welcome to the hard factoring video. Now, I'm not saying that other factoring is easy, but in this case, we are going to be factoring when that a value or the number out in front of our largest term is not 1, which can be pretty difficult. So there are 20 questions here on this worksheet. I don't even think we're going to cover all of them with this video as well as the Go formative, so just keep some of them as extra practice. But in this video, we're going to be going over problems 1, problems 2, problems 10, 11, 12, and 13. So we're going to go over these 6 problems in this video. The reason that I star these is because there's not enough space here, even if I zoomed in really far, for me to do some work. So just know these are the problems that we are going to be going over, and I'm going to zoom down to start those. But first, I want to talk about, I'm going to be using a box, or the box method, I'm using air quotes, and I want to just remind you what that's like. So for instance, we were talking about a poster or a quilt, as you did in AGS 2. You had something, for instance, like this, and you had something with x plus 2, and you, let's say, had 3x minus 1, you would use each of these boxes as its own kind of area model or quilt. So if we wanted to take these two factors and multiply them together, this box would be x times 3x, or 3x squared. This box would be 2 times 3x, or positive 6x. This box here would be x times negative 1, which is a negative x. And this box here would be positive 2 times a negative 1, or a negative 2. So we take all the inside of the box, the 3x squared plus 6x minus x minus 2, and combine this together in any way we could. So we would have 3x squared, in this case plus 5x, minus 2. And this would be our final answer. Now, we're going to be doing the exact same thing, but opposite. We're going to start here. We're going to have to break it up into 2 separate parts here, so we have enough information to fill out all 4 boxes. And then we're going to factor things out to find our side lengths and ultimately have 3x minus 1 times x plus 2. That's how we're going to work through this. We're doing the same method we already know how to do, but backwards. So let's get started. You'll notice for problems 1 and 2, they're actually already in 4 parts because we're not dealing with a square, we're dealing with a cube. So let's take a look at problem number 1. Problem number 1 is 5b cubed minus 7b squared plus 20b minus 28. So just like in the box above, I'm going to draw my box, instead of knowing the side lengths, we're going to put everything on the inside. So we can see that my squared goes here, or my highest term goes here, and my other value goes here, or my constant goes here. So that means we'll have 5b cubed up here. We'll have negative 28 down here. And then in our other box, it was just an x and an x because they were the same. In this case, we do have a squared and then just a b. So the squared is going to go in the upper left-hand corner. Got plus 20b down here. So I want you to notice that I'm bringing the positives and the negatives along because that's going to help us when we factor. So when I take a look, I look side to side and I look up and down. So I look this way between my 5b cubed and my negative 7b squared, and I go, what do these two things have in common? Well, look at the 5 and the negative 7, and I'm like, those don't have anything in common. But b cubed and b squared have a b squared in common. So I'm going to write that on the outside. So if we keep looking sideways, I might look this way at a positive 20b and a negative 28. Well, b, this one doesn't have a b, so we can't pull out a b. So I think, what do positive 20 and negative 28 have in common? And the number that goes into both of those is a positive 4. So we have our first side length of b squared and a positive 4. Next, we look up and down. There's two different ways we can do this. We can look here and go, okay, negative 7b squared and negative 28, what do they have in common? Go, well, they have the negatives, and then 7 goes into both negative 7 and negative 28, so we can pull out a negative 7. You can also ask, hey, what times 4 is going to get me to that negative 28? Answer, negative 7. So we do like b squared times negative 7, we get negative 7b squared. 4 times negative 7 gets us negative 28. So you can either look up this way what we have in common between 5b cubed and 20b, or we can ask ourselves, what do we need to multiply to b squared to get to 5b cubed? Well, we're going to need this 5. We have a 5 in common right here. And we're also going to need a b. So we have our side lengths right here of b squared plus 4. And to get that area we're going to multiply that by 5b minus 7. And these right here, these side lengths, these are our factors. So let's try that again. Let's try that with problem 2. So let's say this is going to be 24k cubed minus 30k squared minus 28k plus 35. So when I set up the box, my top left is going to be my highest value, so 24k cubed. Upper right is going to be negative 30k squared. Bottom left is negative 28k. And lastly, positive 35. So now we have to go through find out what are the side lengths that we could possibly have. Well, what do 24k cubed and negative 30k squared have in common? Well, they're going to be a k squared, and with the 24 and the negative 30, they both have a 6 in common. So it's going to be 6k squared. And I can look along here, okay, positive 35 and negative 28k. What can I pull out of here? Well, this one might be a little tricky. I see there's a negative here and a negative here, so I know these things have to be negative at some point. So if I get a little stuck, I might move to a different spot and say, hey, what do I need to multiply to 6k squared to get to a negative 30k squared? Well, that answer is going to be a negative 5. So I go, hey, well, this negative 5 needs to be multiplied to something to get to a positive 35. So we're going to have to multiply it by another negative, in this case 7. So if you get to a part and you're a little stuck, try another place and you'll be able to fill it back in later. Lastly, we have this area right here. So what do 24k cubed and negative 28k have in common? Well, they're both going to have a k that they can factor out. And as for the number, 24 and negative 28 have a 4 in common. So these right here are our side lengths of 6k squared minus 7 and 4k minus 5. And those are our factors. But what do we do if it's not already set up into 4s, right? Like all the other problems, they only have 3 terms. So what do we do then? Well, let's try this out. I'll move this up just a little bit. Here we go. So for problem 10, we're moving back around now. Problem 10, we got 3b squared minus 2b minus 40. So we're back to 3 terms, but we need to break it up. We need to break this 2b up into 2 different terms somehow, kind of like what we did in our green example. So what we're going to do is we're going to look at the values of a, b, and c for our coefficients. I'm going to draw a little diamond here. In this top part, we're going to put our a value times our c value, or in this case 3 times negative 40, giving us negative 120. And down here, we're just going to put our b value, which is negative 2. Bring those negatives along. Now what we're going to do is we're going to look for 2 numbers that multiply to negative 20 and add to negative 2. Feel free to use some guess and check in your calculator, but I can let you know right now that these 2 numbers are going to be negative 12 and 10. So I'm going to use these values to break up this second term here into 2 different parts. So we can rewrite this as 3b squared minus 12b plus 10b minus 40. So again, if we took negative 12b and added 10b, this is what we'd get. If you had these two switched, that's also okay. But now we're going to take all four of these parts and put them in the box. And then we just proceed as normal. So this just takes one extra step. So we'll have 3b squared. I know that negative 40 goes in the bottom of right-hand corner. And now it doesn't really matter what you put in the upper right or in the bottom left because they're both b. So you're going to get the same answer either way. I'm just going to put negative 12b up here and a positive 10b down here. And see what we can factor out. Well, if we start with up and down, negative 12b and negative 40, I can pull a negative 4 out of both of those. For 3b squared and 10b, 3 and 10 can't pull anything but the b's. I can pull out a b. And then I might ask myself, hey, what do I need to multiply to b to get to 10b? I'm going to multiply it by a positive 10. And I know I've done this correctly because, hey, negative 4 times 10 gets us negative 40. Lastly, over here, you can ask yourself, what do I need to multiply to b to get to 3b squared? What do I need to multiply to 4 to get to negative 12b? What do these have in common that I can factor out? And in this case, your answer is going to be 3b. So if your sides are swapped, that's okay. And if you found your answers in a different order than I did, that's okay as well. But we'll get 3b plus 10 times b minus 4. And there are our factors. We'll try this once more, and then we'll talk maybe about a few other different types of problems that get a little bit interesting. So I'm going to move this up so we can work on problem 11. Problem 11 is 7v squared plus 45v plus 18. So again, I need to break that middle piece up into two different parts. And put our a times our c value here. So in this case, 7 times 18, or 126. And our b value is going to go down at the bottom of 45. So again, we're looking for two numbers that multiply to 126 and add to 45. I'll let you know, this is not something that I knew off the top of my head. I had to play around in my calculator a little bit. But I found that 3 and 42 worked as our answers. So we can split up that middle value into 7v squared plus 3v plus 42v plus 18. Again, if you had these switched, that's totally okay. But when we write these up in a box, there we go. We'll have 7v squared plus 3v plus 42v plus 18. I just kind of write it in the order that I see it. So let's see from here, if we go up and down, 3v and 18 have a positive 3 in common. Notice how I'm not just writing 3, the plus 3 is important. Then we'll see 7v squared and 42v. We can pull out a positive 7, we can pull out a v. So we'll have a 7v right here. Then I might ask myself, okay, sideways, 7v squared and positive 3v, what do they have in common? Only a v. And then 42v and 18, what do they have in common? Only a positive 6. So our side lengths become our answer of 7v plus 3 and v plus 6. Knowing your multiplication tables is going to be really important for these problems, but keep in mind you can use your calculator if you need some help. Let's try two more problems, and these are going to be slightly different, have slightly more of a flair, but they'll go pretty quick. So let's take a look at problem number 12. Problem number 12 is going to go real fast. So problem number 12 is 9k cubed plus 21k squared. So I look at that, I'm like, how do I put this into groups? I mean, there's not even 3 pieces, let alone 4 for me to do. So instead of making a box, I'm going to look at this and go, well, what can I divide out anyway? And I'm going to look at it as if I was just looking at the top row. So if I was just looking at the top row, what could I factor out? Well, 9 and 21 have a 3 in common, and k cubed and k squared have a k squared in common. So if I was able to factor these out, or divide these out, 9k cubed divided by 3k squared is going to give us a 3 and a k, and 21k squared divided by 3k squared is going to just give us a positive 7. And there we are, we're done. So sometimes you don't always need to create the big box and do everything. So I just want to make a note that sometimes you can just divide out the greatest common factor. The greatest common factor, you may have heard this as the GCF in the past. It just means what's the biggest thing we could pull out. So I look at this and I go, I can pull a k out of here and a k out of here, but even larger than that, I can pull out a k squared. So looking at those types of pieces. So keep in mind, we might have some problems like that, not too bad. Let's try just one more problem. Let's take a look at problem number 13. So for problem 13, we have 2x cubed plus 23x squared plus 63x. Now I look at this and I go, you know, this seems kind of busy. I notice that right away I can divide something out of all of these. So before we get into making our square, I look at something like this and I go, wow, there's x's in every single one of these. I'm going to divide out an x. I'm going to do x times 2x squared plus 23x plus 63. I go, you know what? That stuff inside the parentheses, that kind of looks like problems 10 and 11 that we are working on. And that's, and that's exactly what we're going to do. So after we've factored out that x, we're going to make sure that we don't forget it, but we're going to use just this information as we normally would. So we got our A, our B, and our C. We're going to multiply our A value times our C value. So in this case, 2 times 63. Going to get us 126 again. We'll put our B value down here of 23. We're looking for two numbers that multiply to 126 and add to 23. So again, this took me some trial and error when I first did it, but I found that 9 and 14 was a good pair. So when I write this out as one equation, well, if x times, don't forget that x out in front, 2x squared plus 9x plus 14x plus 63. So when I draw out the box, just use what's inside the parentheses. We got 2x squared, a positive 9x, a positive 14x, and a positive 63. So when I look up on my right side, 9x and 63, they both have a positive 9 in common. When I look at 2x squared and 14x, what can I divide out of both of those? I can divide a 2 and an x. For looking side to side, 9x and 2x squared only have an x in common. And then 63 and a 14x, they both have a positive 7 in common. So when I write out my answer, don't just tell me the answer is 2x plus 9 times x plus 7. That's not the full answer. Make sure to bring down the x with it. And that is your final answer. So we've gone through a few different problems of factoring when that a value is not 1. Rewatch this video if you need to. Let me know if you have any questions, and I look forward to seeing you the next class period.